Okay. Okay. So first of all, do you guys know me? Okay. Okay. So let's first talk about me, that why I am a credible person to teach these topics to you. So, like all, you have went through this phase of JEE and engineering entrance preparation, right? I have also went through this. So I was also preparing for JEE. Then I got something. Okay, so I got something 98.8 percentile in JEE mains, like some 10,819 rank, general rank. Then I also applied for WBJEE and got AIR 433 there. Then through WBJ, I got into Jadavpur University, basically, in IT branch. And I spent my first year there. I studied there. And then I came to know about Scalar and this Scalar School of Technology. And I liked their concept very much. So I decided to drop Jadavpur University and join Scalar. And honestly, I don't have any regret dropping my previous college. So yeah, that is after coming here, I have learned many things, and like I have interned at Xerox PPL. You may know. Then, I went through ICPC regionals in 2025. So yeah, these are a little bit of achievement I have. Okay, so uh, also there. Okay, I'm going to say that how I am going to go with the flow of the class. So obviously PNC is a very big topic, and I cannot cover everything in this master class, obviously. So I have designed the master class in a way so that the important topics, the kind of questions that comes in NSET, are basically getting covered. And also I will teach some fundamental concept about PNC, and then we'll also solve some questions based on the concepts. And for SET also, I'm going to give some fundamental understanding of sets and their basics and all. Then we'll move to questions. So this is going to be the flow of the class, and also at the end there is a surprise. So there will be a quiz, and based on the scores of the quiz, top 3% participants will get something crazy. So watch till the end and attempt the quiz at the end. Okay. So the duration of the class is going to be nearly 1.5 hours. Then we'll have some doubt session and all, and then we'll give the link of the quiz where you can attempt the quiz. Okay. Okay. So now let's start with the class, right? Everyone aligned? Okay. Okay. So give me 1 minute. Share my screen. Yeah. So is it visible, everyone? Okay. Okay. So first of all, we'll start with PNC, right? So at the beginning, we have the fundamental principle of counting. So multiplication rule. What does multiplication rule says? That if a work A can be done in M ways, and another work B can be done in N ways, and C is a work that is done when both work A and work B are completed, the number of ways to complete the work C is M into N. Okay, let's understand this with an example. Let's say there is a place A here, and there is a place B here, there is a place C here. So I am saying that let's say there are two ways to go from A to B. You can go in these two ways from A to B. And also there are three ways to go from B to C. Right? So now if I want to know that to go from A to C, how many ways are there? What will be the answer? here? Anyone in chat? 2 into 3, 6, right? So there are two different events that is going from A to B, and another event is going from B to C. And when there is a AND, right? So if you want to go from A to C, there is an AND event is that you have to first go from A to B, and then also you have to go from B to C. So whenever there is an AND, we just multiply the number of ways. So here we are going to multiply 2 into 3, so we are getting 6. Okay. Okay, so now there another rule is addition rule. What addition rule says is that if a work A can be done in M ways and another work B can be done in N ways, and C is a work that is done when either work A or B is completed, the number of ways to complete work C is M into N. Okay, so let's see this scenario also. So let's say there is a room. There is this room, and this is the outside. This is inside. And now you are inside the room. Okay, and you want to go outside. So there are two doors at the let's say this is the front and this is the back. Okay, so there are two doors at the front and there are three doors at the back. So if I now want to know in how many ways I can go outside from inside, what will be the answer? So see, in this case, what we can do, either I can go from the front or I can go from the back, right? So here we have that either F or B. So in such case, when there is OR, we used to add those two number of ways, right? So in case of AND, we multiply the number of ways, and in case of OR, we add. So we'll get 5 ways, right? So this is very basic fundamental thing, right? Okay, so now let's move to factorial notation, meaning of n factorial. So I guess most of you know n factorial. Is there anyone who doesn't know? Okay, so let's explain. So let's say there are n places. And you have n items, right? So if I want to say that in how many different ways I can arrange those n items in n places. So how can I solve this problem? So if I just do this, for the first place, I have n number of items. From there, I can choose any of the item, right? So here we will have n possibility. Then in the second place, I have already chosen one item, right? So I now have n minus 1 items left with me. So here will be n minus 1. Then we will have n minus 2. And all this thing will be n minus 3 up to, at the end, we will have one ways only, one item I will be left with, right? So now see, these all are in AND. So for this place, there are n possibilities. And for the second place, we have n minus 1 possibility. So these are all going to getting multiplied, right? So my total number of ways will be something equal to n multiplied by n minus 1 multiplied by n minus 2 all the way up to 1. Correct? Okay, so in permutation and combination, in most of the questions, we mostly use this kind of thing. There are many questions in which we are going to use 1 multiplied by 2 multiplied by some value. So that's why to represent this in a efficient way, we just call it n factorial. So n factorial is nothing but the multiplication of from 1 to up to n, multiplication of all the integers. Okay. Okay. So let's now move on to the next concept. So this is all. This is a very important concept in order of NSET, basically. So the concept is exponent of prime in an n factorial. So do you guys know the formula for this? Let's say I want to find the power of p, where p is a prime number. Let's say I am saying for now is a prime number in n factorial. How to find it? Do any of you know it? There is a very famous formula actually. Okay, so if you don't know, I am going to explain it. So step of n by prime number. Okay, so I'm going to explain it. So the formula is basically, what you do is that, let's say you have to find the power is going to be equal to, this is a GIF function that is given divided by n divided by p plus n divided by p square, then you have n divided by p cube, and all the way up to until it doesn't become 0. So this is a GIF function, right? GIF function, what does GIF function do? Greatest integer function. So if you write 2.34, greatest integer less than or equals to 2.34 is 2, so it will give you 2. So there will be some point in this sequence where after some time p to the power something, let's say k, will be greater than n. In that case, we'll have this n divided by p to the power k is less than 1, right? And in that case, we will get 0. So after that, we don't need to do any calculation to calculate the power of prime number in the n factorial. So now this is the formula that many of you may have seen, but how this is working, right? So what is the intuition behind it? So let's take an example. Let's say I'm going to find the power of 3 in 100 factorial, right? So first of all, what is 100 factorial? If I write 100 factorial, it is nothing but 1 multiplied by 2 multiplied by 3 all the way up to 100, right? That is what just we have learned before. Okay, so now if I segregate the values, and let's say what I can write it is as that 100 factorial equals to, let's say I am taking all the multiples of 3 at the first. So if I take all the multiples of 3 in a separate bracket, I guess, so it will be 3 multiplied by 6 multiplied by 9, 12, and all the way up to 99. I am keeping this aside and I am taking all the values at the other side. So why I am doing this, right? Also, can you see that in 1, 2, 4, 5, and all those numbers that are not multiple of 3, I cannot get any power of 3, right? Understanding? Okay, so now I am segregating all those values. So I will get 1 multiplied by 2 multiplied by 4 multiplied by 5, then I'll not get 6, I'll get 7, 8, and all the way up to 100. I don't care about these things. I don't care about these terms. Now I have all those terms, and I know all of them are divisible by 3, right? Okay, so now if all of them are divisible by 3, let's divide them and let's make them shorter. So if I can just write it as 100 factorial equals to, now see how many terms will be there from 3 to 99. How many terms will be there? 33, right? So I'll get 3 to the power 33 here, and I can divide all of them by 3. So if I divide all of them by 3, I will get 1 multiplied by 2 multiplied by 3 up to 33, right? Basically 33 factorial. Okay, and I will have these terms also in other place. That doesn't matter much to me. Okay, then again, now see, here I am getting 33 factorial, right? So here there will be also some terms where I can get 3 as my that I can get 3 my factor from there, like numbers 3, 9, 12, all the way up to 33. So I can again segregate these terms. So if I again segregate these terms, I will get 3 to the power 33 multiplied by, I'll get 1 multiplied by 2. So first let's take the multiples of 3's. So if I take the multiple of 3's, I'll get 3, 6, 9, all the way up to 33. Now I will get only up to 33, right? Okay, and also I will get some terms that are not multiples of 3, 1, 2, 4, 5 and all again. And I will also have this terms, right? So 1, 2, 4, 5, all this. Then again, I can do the same thing here. I can divide all of these terms by 3 and I can take the power of 3 outside, right? So if I just do this, how many terms are there now? 11. So there will be 11 terms. So I will get again 3 to the power 11 here. And I will get 1 multiplied by 2 all the way up to 11. So again, I will get these terms. I'll get 1, 2, these terms. That doesn't matter to me for finding the power of 3. Then again, in this 11 factorial term, I can again get some powers of 3, right? So if I again segregate this, I'll get something 3 to the power 33 multiplied by 3 to the power 11. Then I'll get 3, 6, 9. Only this 3, right? And we'll have this different terms. Again, I can divide these terms by 3 and I can take out the power of 3, right? So what I'll get again 3 to the power 33 multiplied by 3 to the power 11 multiplied by 3 to the power 3. Again 1 into 2 into 3 and all these terms. Then what I can do, again I can segregate from here. And what I can write it as that 33 3 to the power 11 multiplied by 3 to the power 3, and there is 1 3, so I can divide it by 3 and take out this one term here. So 3 to the power 1, right? Okay, and there will be now all the terms will not be there will not be any terms which is divisible by 3 now. So I have got all the 3 powers separated. And as you know that a to the power m multiplied by a to the power n is basically equals to a to the power m plus n, right? So I can just apply this formula now. If I just apply this formula, then I will get 3 to the power, so 33 plus 11 plus 3 plus 1. So 3 plus 1 is 4, 15, so 48. So 3 to the power 48. So I know that 3 to the power 48 and I have those terms that is not divisible by 3 now. So the maximum power of 3 in 100 factorial is 48. So got the idea, like how we can calculate the thing. Now let's talk about that why this formula, right? Why this formula? How we are getting this formula? So first of all, when you have 100 factorial, you are taking all the multiples of 3 at the first, right? So how many numbers will be there that will be divisible by 3? So can I say that there will be n by 3 numbers which will be divisible by 3? That is, for every 3 number, I will get one number that is divisible by 3. Like for 1, 2, 3, I will get one number, right? So if I just divide by 3, I will get that how many multiples of 3 are there, right? Is it making sense? Okay. So then when I have already divided the numbers that are a multiple of 3 by 3 once, then again, what are the remaining numbers that will be divisible by 3? That all will be the higher power of 3, right? Let's say I was having 9 initially. I can divide 9 by 3 once, and then again I can divide it by 3 to make it 1, right? So in the first go, I have reduced the powers of all the multiples of 3, but the numbers that are having higher powers of 3, 3 to the power 2, 3 to the power 3, and multiples of all of this, Like for 9, I can also divide it by 3 two times. For 18, I can also divide it by 3 two times. Like, not for 18. Yeah, so for 18, I can divide it to get 6 and 2, like this. So all the higher powers of 3 will have again 3 remaining uh, term, in their value, right? So that's why I am doing. And also, how many numbers will be there? That is, first of all, first when I have divided all the numbers by 3, uh, all the numbers, that is 3, 6, 9, 12, 15, 18. Let's take these numbers. And also let's take 81. So once I have divided all of this by 3, I'll get 1, 2, 3, 4, 5, 6. And this will be 27. Right? So now, what are the numbers that are remaining that can be divided by 3? So it will be 3, 6, 9, and all those the multiples of 3, which were previously the multiples of 9, right? Is it making sense? Okay. So again, when I divide these numbers by 3 again, I'll get 1, 2, and also here I'll get 9. Then I can also divide it by 3 to get 3 and then 1, right? So this is why I am going to every powers of every powers of p, and I am dividing it to get how many numbers are there, how many multiples are there with that power. So that many time our power will be added at the end. So like in this process, we'll get, this is for all the multiples of 3, then this is for all the multiples of 9, then this is for all the multiples of 27, and all, and so on. Okay. So this is the basic idea behind the exponent of prime in factorial. Are you all getting it? Okay. So let's now solve this question then. How many zeros are there at the end of 2025? So how can we solve this question? So it is saying that how many zeros are there. So for zeros, I have to get the power of 10, right? So I have 2025 factorial, and I have to get the power of 10. But 10 is not a prime number. 10 is not a prime number. So how can we get? So in that case, what we can do, that we can write the prime factorization of 10. What will be the prime factorization of 10? 2 into 5. Simple. Now, I know for sure that the power of 2 will always be greater than the power of 5 in 2025 factorial, because 2 is a smaller number, so I'll get more also more multiples of 2, multiples of 4, and all, then just multiple of 5, 25, 125, right? So if that makes sense, we can just count the power of 2 in 2025 factorial to get our answer. Is it making sense? Okay, so let's now solve this question. So now see, you know the intuition behind the formula, but when there is any question that coming in your exam, you are not going to go by the intuition. You are going to apply the formula directly, right? Because it will save your time, and time is very important in NSET exam. Okay, so how we can get the power is that power is equals to 2025 divided by 2 plus 2025 divided by 4 plus 2025 divided by 8, and all the addition up to 2025 divided by 1024. That is a power of 2 to the power 10. Right? So if you just calculate this answer, and also if there is any point answer, like here I'll get 1012.5. So I am just going to add 1012, not 1012.5. That is a GIF function. Okay. So in this way, you can calculate the answer and get the result. Okay, so now let's move on to our next concept, that is permutation and combination formula and what it means in tuition of NPR. So let's the number that we get in first division, just keep dividing it by 2 again. Yeah, you can also do that, and that is a very good intuition you have came to. That is, I am getting 1012, then because I am just dividing the previous answer by 2 only, so I can just divide it by 2 and get the answer as 506, then 258 253. So again, you can do it in any way. Way, if you find that you can save time, go for it. So then, intuition of NCR and NPR. So let's say there are R places. Now we don't have N places, we have R places. Okay, and we want to find, and we have N items again. We want to find that in how many ways we can arrange those N items at R places. That is the basic fundamental meaning of NPR. So what if I just simply solve it in my intuition, I can say that there are N possibilities here, then there are N minus 1 possibilities here, I have N minus 2 possibilities there, all for the first position, for second position, third position, and for rth position, how many possibilities I will have? I will have N minus R minus 1, right? So basically it will be N minus R plus 1, right? And again, from the fundamental rule of counting, all those positions are independent of each other. So we need AND of all of this. So I am going to multiply all this. So basically my formula for NPR will be equal to N multiplied by N minus 1 multiplied by N minus 2 all the way up to N minus R. Let's say N minus R minus 1. This is the thing. Okay, so now if I manipulate this formula and do something like I already have up to R minus 1, right? So if I do something that N multiplied by N minus 1 multiplied by N minus 2 and go up to N into N minus N minus R minus 1. And I am just adding some other terms also here. So I am going to add N minus R, N minus R minus 1, and all the way up to 1. And I am also going to divide it by all the terms that I have added above. So it will remain same. So I can write that NPR equals to this. So what I will get, N minus R multiplied by N minus R minus 1 multiplied by all the way up to 2 multiplied by 1, right? So if I just go and see the N factorial, what is the meaning of N factorial, then I can write it as that NPR is equals to nothing but N factorial, because it is going from N to 1, right, totally. So I can write it as N factorial. And in the below, I will have N minus R factorial, because it is going from N minus R to 1. So this is my formula for NPR. And this is basically the number of ways in which N items can be placed at R different places. N different items can be placed at R different places. Number of ways in which I can arrange. Okay. So now also let's get the intuition of NCR. What is NCR? So NCR basically says the number of ways to choose R items from N items. Okay, so now let's see how can we get the formula for NCR. So let's say I have chosen, I know that the number of ways to choose R items from N items is this, right? So if I say that I have chosen R items from N items and now I want to arrange those R items, right? So in how many ways I can arrange R items at R different places? Guys, is there anyone who know the answer? In how many ways I can arrange R items at R different places? So we have done it previously, right? We have shown here, right? When I was telling that n factorial, there were n items and n different places, and you have first n possibility, then n minus one, n minus two. Yeah, just divide nbr by r factorial. So what I am going to get is that NCR, and then if I arrange those in selected R items at R different places, I will get this number of arrangement, right? And again, I have just solved this problem previously. That was NPR. So I can write in this is nothing but equals to NPR, or it is equals, this is equals to n factorial divided by n minus r factorial. So from there, I can deduce that NCR formula is nothing but n factorial divided by n minus r factorial divided by r factorial. So that's how NCR and NPR come into picture, right? Okay, so now let's move on to our next question. So the question says, how many different signals can be given using 5 flags of different colors? So how can you solve this question? You have 5 different color flags. So basically you have 5 items, 5 different items. How many arrangement can you make from 5 different items? Now see, this is one kind of tricky question because you have to consider that when you are making the signals, you can take one item to make the signal, you can take 2 items to make the signal, you can take 3 item, 4 item, 5 item. So you have to calculate for different all the cases, and you have to add those different cases, because all of this there are or that I can take either 1 item or 2 item or 3 item. That is fundamental principle, right? So what I am going to do is that, so now see, you have 5 different items, you have one place. So one place to fill that. So how many ways I can arrange it? So I will get 5p1 for if I am taking only one item to give the signal. Then for 2 item, what I will get, I will have 5p2, then 5p3, then 5p4, then 5p5, right? And addition of all this will be the answer. Okay. So now the next important topic is that later permutation. This is also one of the famous topic for NSET. So it basically says that if you have some letters, or let's say some digits, so you have a number where there are some digits, all the digits I'm showing by A1, A2, A1, like that, right? So if the number is something like A1, A2, this is a digit, this is also a digit, and all of these are digits. So I'm getting A1, A2, then A3. Let's say there are A2 again, then A2 again, then there is A1. So in how many ways I can arrange those numbers to get how many different arrangements are possible? So in this case, what I do is that I get the frequency of each of the digits. When I get the frequency of each of the digit, let's say A1 appeared 2 times, then A2 appeared 3 times, and A3 appeared only once, right? So if I want to get how many total number of ways in which I can arrange those to make different number of different numbers, basically. So what I will do, I will at the top number of ways. Yeah, you are right. So number of ways will be the total number of items factorial. Here it is 2 plus 3 plus 1, that is 6. So I'll get 6 factorial divided by 3 factorial, 2 factorial, and also 1 factorial, which is 1, so we don't need to write it. So yeah, in this way, you can get a letter permutation. In this kind of questions, you can solve it using this basically trick. Then you have this question, is that how many ways the letters of the word arrange can be arranged such that the vowels are always together. So first of all, let's write the word arrange. So in arrange, how many A's I have? I have 2 A's. Then I have 1 E. Then I have 2 R's. Then I have 1 N and 1 G. Right? And among these, there are only 3 vowels. Like 2 vowels, the total frequency is 3. And I want that these two, like the vowels, always together. So I am going to consider these as a total set. I cannot divide it in different positions, right? Consider all the vowels at once. So what I am going to do, I am taking this as a set, and inside this, in how many ways I can arrange those vowels? In how many ways? We have total 3 vowels. So 3 factorial divided by the frequencies of each. So I am going to divide it by 2 factorial because 1 factorial is 1. So that is 3 factorial by 2 factorial. And then I have considered this A, E as a total different element. A different place is basically there for this A, E. And I have also some different letters, that is 2 R's, 1 N, 1 G. So I can arrange all of this. So how many places I have? If I consider this as only one place, so I will have 2 places for R, 1 N and 1 G. So I have total 5 places now. Total 5 places now. And I can now arrange this in how many ways? How many ways I can arrange this? Now also see that there are 2 R's. The frequency of R is 2. So again, I am going to apply that same letter combination formula. So how many total places I have? 5 places, out of which 2 places are identical. That is 2 R's are identical. So I am going to divide it by 2 factorial. So this is going to be your final answer. Okay, make sense? Okay, so now there is another important concept for, okay, why divide by 2 factorial? Okay, so because as I already previously said that, like for letter permutations, what we do is that in how many frequencies something is occurring. So see, here I have this as a element, then I have also 1 R, 1 N and 1 G as an element. So these 2 are identical, right? These 2 are identical. So for that, we can divide it by 2 factorial. Are you getting it, Harsh? Okay, so let's move on to our next concept, that is at least one concept. This is a very basic concept. That is when I want some at least one thing, the number of ways in which at least one something is selected, something like that questions. There are some questions like that. So I can say that at least one, what is it? Okay, so at least one is equals to total number of ways minus none selected, right? Okay, so let's see from the below example that how we can. Okay, so there is no question. Okay, so let's say there are 5 red ball and 4 blue balls, and you have to select. Same problem. Select 4 balls in such a way that you should select at least 1 red ball. Okay, so if this is the question, how you will solve it? You can either say that I can take first different cases, that I can take 1 red ball and see how many combinations are possible. Then I can say I will take 2 red balls, then 3 red balls and 4 red balls. But you don't have to calculate all this. If you just do that, you have 9 balls total, right? So if you just want to select 4 balls out of 9 balls, there are these many possible ways in which I can select 4 balls out of 9 balls. And now I want all those to be removed in which I am not selecting any red ball, right? So in which case I am not selecting any red ball, that is when I am selecting all the blue balls. So I am selecting 4 balls out of those 4 blue balls. So if I just calculate this will be my answer. And you don't have to calculate that different cases, and so it will be easy, and it will like optimize your time. So if you get more time, you can solve more question, and you can basically get a good marks, right? Okay, so now almost all the important things related to permutation and combinations, which are there in your NSET, which are very frequently appearing question in your NSET, are covered. So now what I am going to do is that I'm going to do some questions for you for PNC questions. Okay, so let's see this question. This question says, how many numbers are there between 0 to 10,000, excluding 0 and 10,000? Selected 1 red ball, so 2 combination of other balls. Prajwal, I didn't get your question. What if I do that, sir, if I already selected on red ball, so 2 combination for other balls? Can you repeat your question? So okay, I'm going to repeat the explanation again. That see, the question was saying that you have 5 red balls, 4 blue balls, and you have to select 4 balls where at least you should select at least 1 red ball in your combination. There should be at least 1 red ball. What you can do is that you say that I want to select 1 red ball. So what you will do, you will go and say, out of 5 red ball, I am going to select 1 red ball, and out of 4 blue balls, I am going to select 3 blue balls. Right? This is one way. Okay, so I'm going to explain. So then for red ball, I'm going to select 2 red ball now, and also I'm going to select 2 blue balls, and so on. So like then I can select 3 red balls and 1 blue balls, and also I can select 4 red ball and 0 blue ball, basically. So this is one way in which you can solve this question. And also there is other way, is that you get all the combinations in which you can select 4 balls out of all the balls, and then you subtract all those cases when there are no red balls. So when there are no red balls, what you mean is that you are selecting all the blue balls. So if you just select all the blue balls, that is 4C4. From 4 blue balls, you are selecting 4 balls, right? So that's how this was done. Is it making sense? Okay. Okay, so let's move on to our next question. How many numbers are there between 0 to 10,000, excluding 0 and 10,000, with the property that no consecutive digits are same in the number? Okay, so I have to find out first of all, no consecutive digits are same. Now, let's do something. If say I have a number which is m digit number. Let's say there are total m places, right? This number is m digit number. Okay, so now if there is m digit number, in how many ways I can create a m digit number? What will be my number of items I can place in this position? How many digits I can place in this position? As I am saying, this is a m digit number, right? So you cannot place 0 at the first place, because then the number will not be an m digit number. It will be less than that, something m minus 1 or m minus 2 digit number. Yes. So I have total 10 digits, out of which I cannot place 0 here. So I'll have to place either one of those 9 digits that is not 0 here. So I will have 9 options here for this place. Okay. So then for this place, what I can do is that I am saying that I don't want any consecutive digits in the number, right? So the number that I have placed before, I cannot use it for the second place again, right? So if I just do this, I'll have one digit that is already present in the previous. I cannot use that. So I'll again have 9 possible ways to fill this digit. Yes, we can use 0. Yeah, because in this position we are not using any 0, right? So it will be something 1, 2, anything. But if you have placed 1 here, you cannot place 1 at the next position, right? So that makes your number of ways to fill this place 9, right? Again, if you have placed anything here, let's say 4 you have placed, then you cannot place 4 at the next position. So you can place any of the other digits out of those 10 digits except 4. So you will again have 9 options to fill this place, right? And in similar way, all of those places will we can fill all those places by 9 ways. And again, all those places are, we are doing and here, that for this position I can fill it in n ways, and I can fill this place in 9 ways, and we are doing and. So we are going to multiply all of this. So if I just multiply all of this, what I'll get 9 to the power m, right? Okay, so for m digit number, I am getting 9 to the power m. And I have to find from 0 to 10,000, excluding 0 and 10,000. So I have to find from 1 to 9999. So can I say it is something that 1 digit numbers plus 2 digit numbers plus 3 digit number plus 4 digit number, right? So if I just want to calculate it, what I can do is simply that 9 to the power 1, because here m is 1 digit number. So for 2 digit number, I will have 9 to the power 2. For 3 digit number, I will have 9 to the power 3. And for 4 digit number, I will have 9 to the power 4. If you just calculate it and add it, you will get your answer. Okay? Make sense? Yeah. So this was a good question. Then, okay. So yeah, so this is a kind of question that is also very common in NSET kind of papers. That is, you have to do something case wise. You have to take different cases and solve those cases to get your answer. So let's see the question. What it is saying is that you are designing a secret code for a treasure hunt. The code must be a 4-digit number, where the smallest digit is 3 and the largest digit is 7. How many possible codes can you create under these conditions? So your smallest is 3 and largest is 7. right? And you have to create 4-digit number. So there are 4 places you have to fill. So what are the digits you can use? You can use from 3, 4, 5, 6, 7. Okay, so PDF of the session note. Yeah, so like we'll try to provide you the session note. We can email you the session note. Is that fine? Okay. So these are the digits you can use. Now see, you have to say how many possible code you can create. So they are basically asking for total number of arrangement, total number of permutation you can create. Now see where I have to take different cases and I have to solve this question. Why, right? So let's go to different cases and see why we have to solve this question in different cases. So let's take the case 1 where I am saying that I know for sure that if my smallest digit is 3 and largest digit is 7, so I know for sure that 3 and 7 are going to present in that number, right? So I have to take care of the other 2 places that are going to filled, right? I know that 3 and 7 are going to be in my number, and there are 2 other remaining places that I have to fill. Now let's say for case 1 I am saying that the other 2 places I am having 3. If I am having 3, so what will be my number? Like it will be something 3 3 3 7. So how many different combinations, how many different permutation arrangement I can make out of these numbers? 3 threes and 1 7. Again, the later combination type question, right? So how many combination we can create? That is basically 4 factorial divided by 3 factorial. So it will be basically equals to 4. Then for case 2, I am saying that my other 2 numbers will be 7 and 7. It was 3 and 3 here. I am having 7 and 7. Then again the same case, right? There are 3 sevens, 1 3. So how many permutation I can create? That is 4 factorial divided by 3 factorial. That is equals to 4. Okay, so now let's take a different case. Case 3. Case 3 is where I can have 3 and 7. And I have 2 places where I will place any of the number from 4, 5 and 6. I will not place 3 here, right? So from 4, 5, 6, I'm going to take any number and I'm going to place it twice. So what I am saying, I am, let's understand this. Let's say I am picking 5 from here. From 4, 5, 6, I am picking 5 and I am using it twice. So what I will get 5, 3, 5, 5, 7. All these combinations that are including 3, 2 5s and 7, and for all those 3 numbers. So how many ways I can get the permutations? That is from those 3 I have to first select one. So I will have 3 possible number of ways to select a number. Then I have the frequency 2 here and total number is 4. So I am going to get 4 factorial divided by 2 factorial number of ways in which I can arrange these numbers, right? So if I just calculate it, it will be 3 multiplied by 3 into 4 is 12. So it is going to be 36. Then what I can say is that I have a different case, which is case 4, which is equals to 3, 7. And for the other 2 places, I can choose 2 numbers from 4, 5 and 6. 4, 5 and 6 I have. From there, I can choose any 2 numbers and then I will make the arrangements. So if I take 2 numbers, let's say 5 and 6, so I will get 3, 5, 6, 7, something like that. And also all this arrangement of all these numbers. So first of all, I'm going to choose 2 numbers from 3 numbers. So it will be done in 3C2 ways, right? Then in how many ways I can arrange those? Now I know that all my numbers 3, 5, 6, 7 all are different numbers. So from later combinations say or from in factorial concepts say, you can directly say that I can arrange it in 4 factorial ways, right? So if I just calculate it, it will be 3 multiplied by 4 factorial is 1 into 2 into 3 into 4 is 24. So 24, that is 72. This is my case 4. Now see, are there any cases remaining? Do you think, is there any cases remaining here? 3377. Yeah, so this is one of the case remaining, right? So let's take this case also. Case 5 is that I have 3, 7, and also for this two, I'm going to get 3 and 7. So in this case, how many permutations we can get? I'm coming to that. So in this case, how many permutations I can get? I can get 4 factorial divided by 2 factorial divided by 2 factorial combinations. Because there are two numbers, that is frequency of both of them are 2. So I can just get this many number of arrangement from here. So if I just calculate it, it will be 6. Then are there any cases remaining? Yes, there are, just as Lashia had chat have. Okay, so let's see that case now. Let's say I have another case where what I am going to do is that I am going to say that I have I have 3 and 7 common, and 2 places are there which I need to fill. So I am saying that one place I am going to fill with 3, right? And the other place I am going to choose from 4, 5, 6, a number from 4, 5, 6. This is one of the possibilities, like we haven't considered it yet. So see, you have to be very careful about selecting all the possible cases, that any of the cases doesn't get eliminated. So your answer will be wrong and you will waste your time in this question and will also not get any score for that. So make sure you complete all the cases. So in this case, what will my my number look like? It will look like something 3, 3, 4, 7. So how many permutation we can get? We can get 4 factorial divided by 2 factorial. Yeah, that is only. So I'll get 12 here. And also there is another case, that is if I say I want 3, 7, dash, dash. For dash, dash, I am going to have 7 and another number is from 4, 5, 6. So for this also, I am going to get 4 factorial divided by 2 factorial permutations. So total 12 arrangements there. So then now you have to add all of those total number of permutations to get your answer. Making sense? Okay. So PNC is mostly done now. We'll now go ahead with set and Venn diagram. So for set and Venn diagram, basic terminology is what is set. Govind. So this kind of question, I'll have a doubt session at the end. So you can just ask me and I'll suggest you. So let's come back to our topic, set and Venn diagram. So basic terminologies, what we can say is that what is set? Set is collection of data, collection of objects, so like that. And also what I have seen is that from analyzing the recent year papers and all the NSET papers, the most useful things, one is that cardinality of set. What cardinality means is that the total number of items in set. Okay, and another concept is there, that is power set. Do you guys know power set? Okay, so if you, set of subsets. Yeah, so basically if I have a set, let's say 1, 2, 3, then what are the subset I can have? I can have first empty subset, then I can have one element subsets, that is 1, 2, then 3, then two element subsets, that is 1, 2, 1, 3, 2, 3, again 3 element subset, that is 1, 2, 3. So how many sets, that's the set of all this. So this is our power set. So if I just say that, let's say denote a set by S. S is a set of some numbers. And let's say the cardinality of set S is 3. So if I denote power set by P of S, so what will be the cardinality of power set? So the cardinality of power set is 2 to the power n. That is, here in this case, the number of element in the actual set was 3. So I will get 2 to the power 3 element in the power set. So basically it will be 8. Right? This is one of the important concept according to NSET. Okay, so now let's come back to intersection union formula. You may have known, but yeah, I'm going to explain it again. So if there is a set A and there is a set B, then what is the formula for A union B is that A plus B minus A intersection B. And again, if I have three sets, let's say A, B, and C also, then for that formula, I'll have A union B union C will be equals to A plus B plus C minus A intersection B minus B intersection C minus A intersection C plus A intersection B intersection C. Okay, so these are the two major intersection union formula. So you can also get the intersection formula from here also. So basically, if I want to get the value of A intersection B, I can just write it as A plus B minus A union B, right? Okay, so let's now move on to a different, very commonly asked questions, that only A, only B, only one, only two, at least one, this kind of question. So now also I'm going to use Venn diagram. Do you all are familiar with Venn diagram? So basically we can represent sets in using this circular visual thing, right? If I say this is the set for A, this is the set for B, this is their intersection and all. Okay, so let's say I have a set A and I also have a set B. Now union intersection is clear, right? This part is our intersection, and the total area for A and B, total area is A union B. Okay, so now let's move to only A, only B kind of concept. So let's first make the Venn diagram. So this is my set A, this is my set B. So if I want to say that only A, which portion should I select? What do you mean by only A? All the elements that is only present in A, they are not present in B, right? So can I say that all these elements, these are only present in A, not in B, and not outside A. So this is my only A. So I can also write it as like A minus B, right? And also if I just want to use the intersection and union formula, I can also write it as A minus A intersection B. Okay. Also, if I want to find only B, then I can also write it as B minus A, which is equals to B minus A intersection B. Okay. Now, if I want to say that only one, that all the elements, find all the elements that are present in only one of the sets, either A or B, not in both of the sets. They are not common. So what I can do is that I can add these two numbers to get our answer, right? Okay. So you can also write it as like A plus B minus 2A intersection B. And this is also, I can write it as A plus B minus A intersection B minus A intersection B. So this is nothing but A union B. So A union B minus A intersection B. So that is the total area that is covering A and B totally minus that intersection portion, right? Clear? Okay. So these are basically the overall concept of sets. Sets don't have much very complicated thing. So either there are mostly two kind of things. One is very frequently asked is that you will be given a condition based on which you have to make a Venn diagram, or you can also do it using the set formulas and all, intersection union formulas and all. You can solve the question in any of the ways, or you can simply make the Venn diagram and get the visualization from there, and you can answer the question. So now what we are going to do is that we are going to solve some questions on set. Okay. So first of all, let's see this question. The question says that a set has been defined as S equals to X, where X belongs to R. R is a real number. And X is a root of this equation. Equation is 2x square. This is x square basically. Minus 5x plus 4. So now what is the cardinality of the set? So you have to say how many numbers are there in this set S. So what is the equation? Equation is 2x square minus 5x plus 4 equals to 0. So what is the solution of this quadratic equation, right? So this is a concept of quadratic equation where you have a formula for Sidracharya basically, that is to find x. What you do is that x equals to minus b plus minus root over b square minus 4ac by 2a, something like that. And this is the thing you call determinant, right? And if the determinant is less than 0, then you will have imaginary solutions. If the determinant is equals to 0, then you will have same solution, basically two real solution. One real solution, one distinct real solution. And if you have this determinant positive, you will get two real solution, distinct real solution. So in our case, what we have, what is the value of d? If I just calculate the value of d, d is equals to b square, that is 25 minus 4ac. 4ac is 4 into 4 into 2, so that is 32. So we are getting minus 7, which is less than 0. So in this case, as I wanted x as a real number, not an imaginary number, right? So I can say, you don't have to even solve the question. You can simply say that I have imaginary roots, so I don't have any real number x. So my cardinality of the set is going to be 0. So my answer is going to be 0. Okay. So let's move on to our next question. Okay, so this is a very good question. The question says that find the count of numbers co-prime with 30 in the range of 1 to 1000. So what do you mean by co-prime? What is the meaning of co-prime? Can anyone say what do you mean by co-prime? Co-prime numbers, when I say that there are two numbers, they are co-prime. Let's say A and B are co-prime. What do I mean by that? Okay, so let me explain. Uh, when I am saying that A and B are co-prime, then I am saying that there are no any divisors other than one which can divide both the numbers. So basically, I am saying that HCF or GCD, what you guys say, HCF of A and B is going to be 1, equals to 1. And this means that there are only one common divisors which is equals to 1. Other than that, both of them cannot be divided by a number that is other than 1, right? So if I want to count the number of co-prime numbers, co-prime with 30 in the range from 1 to 1000, how we can calculate that, how set is going to play a role there, right? That is a question. So let's see. I am saying that there are no common divisors for that number and 30, right? So first of all, let's see what are the factors 30 have. What is the prime factorization of 30, right? So if I just get the prime factorization of 30, 30 will have 2 as its divisor, then it will have also 3 as its divisor, then also have 5. So this is the prime factorization of 30. And I have to find all those numbers from 1 to 1000 such that they don't get divided by any of them, 2, 3, or 5. From any of them, they should not be get divided, because if they get divided by 2, let's say there is a number, let's say 4. If 4 is getting divided by 2, I know that 2 is a number that can divide 30 and 4, both of them. So I don't want all of this. I want all of those numbers which are only the HCF with that number with 30 is 1, right? So I want all of those numbers which are not divisible by 2, not divisible by 3, and not divisible by 5, right? So let's say I'm saying that A is set of all those numbers divisible by divisible by 2. B is all those numbers divisible by 3, and C is all those numbers divisible by 5. So what is our requirements? I want all those numbers which are not divisible by 2, 3, or 5, right? So can I say that I have total 1000 numbers, and from there I want to remove all those numbers which is either divisible by A, like which belongs to set A, that is either divisible by 2, or they are divisible by 3, that is belongs to set B, or they belongs to set C, that is they are divisible by 5. Is it making sense? That I have 1000 numbers, and from there I want to remove all of those which are either divisible by 2 or 3 or 5. So now the concept of set comes into play, that you have to find this value, this cardinality of this set, right? So now if I want to calculate, how can I calculate? So if I just want to calculate how many numbers are divisible by 2, that is n of A, what I can do is that there are 1000 numbers, and all are sequential numbers from 1 to 1000. So how many numbers are divisible by 2? I can get it by dividing it by 2, that how many numbers are divisible by 2, 2, 4, 6, 8, all those sequence, right? So 500. So I can do it that 1000 divided by 2. Now let's talk about 3. If I want how many numbers are divisible by 3, I can get it by 1000 divided by 3. Simple. And also if I want all the numbers which are divisible by 5, I can do the same thing, 1000 divided by 5. Now to calculate this n of A union B union C according to that formula, right? I have to calculate this total thing, number of A intersection B, B intersection C, A intersection C, and A intersection B intersection C, right? So let's see what those means and how we can calculate that. So I now want to calculate all the numbers, number of all the numbers which are divisible by 2 and 3. That is, they belongs to set both A and B. So what are the numbers that is divisible by 2 and also divisible by 3? Can I say that that is a number that is divisible by 6, all the numbers that is divisible by 3? I can say that they are divisible by 3 also and they are divisible by 2 also. So basically what happens is that that are all the numbers that is divisible by the LCM of 2 and 3. So LCM of 2 and 3 is 6. Right. So these many numbers will be divisible by 6. That is, they belongs to A intersection B. Then I want to also find out how many numbers belong to A intersection C. For that, what I will have to do, I will have to do 1,000 divided by LCM of 2 and 5. That will be 1,000 divided by 10. Then again, I have to find out B intersection C, number of numbers that is in the B intersection C set. So for that, I have 1,000 divided by LCM of B. B is 3 and for C I have 5. So this is going to be 1,000 divided by 15. All those numbers. This many number of numbers will be divisible by 15. And again, I have to calculate n of A intersection B intersection C. It will be 1,000 divided by LCM of 2, 3, 5. Which will basically, yeah. So like you have a question is that 1,000 divided by 6 is 166.66. But n cannot be decimal. Yeah, right. So in that case, what you should do? Let's talk about that. I am taking all the multiples of 15 here, right? All the numbers which are divisible by 15. Let's say I was having all the numbers up to 50. Then what will be my answer? How many numbers will be divisible by 15? Can I say that 15, 30, and 45 are the numbers that are divisible by 15, right? Inside from 1 to 50. So I have 3. But if I divide it by 15, it will be something 3 point something. So I don't care about the decimal places, decimal numbers that are after the decimal. So what I have to do, yeah, you like mentioned it. So thank you for that. So what I have to do is that I have to take the GIF here also. That my n cannot be a decimal. So I have to take a GIF to make sure that my total count is an integer. And GIF will give you the lower number, right? So for here 50, you will get 3 numbers, not 4 numbers. So that's why you have to take GIF. And in all of those places, we will take GIF. So if you do this here also, you will get 1,000 divided by 30. Okay, so now you have all the values of n of A, n of B, n of C, n of A intersection B, n of A intersection C, n of B intersection C, n of A intersection B intersection C. You can get the value of, calculate the value of this. And if you minus this value from 1,000, you will get your answer, right? In this way, you can solve this question. This was a very good question where set is also applied, number theory is also part of this question. So yeah. Okay, so now we have a question that is basically, this is mostly based on the Venn diagram thing. Okay, so let's read the question. In Rao Foreign Language Academy, based in Coimbatore, 30 students study French, 40 students study German, and 50 students study Spanish. The number of students who study all the 3 languages is 5. The number of students who study both French and German, both French and Spanish, and both German and Spanish are 15, 17, 13 respectively. the number of students who study at least one language. So as I already said, right, these are very common type of question, that at least once, only one, and only French, only German. This kind of questions can, could be asked in NSET. So you have to be very confident with this kind of question. So let's see. So this is, as I already said, this is a pure kind of Venn diagram based question. So let's write all the data. So I am going to make the Venn diagram at first. So I have French, German, and Spanish. So let's denote it in a Venn diagram. This is for French, this is for German, and this is Spanish. So here, first of all, whenever you get a question of Venn diagram, try to find the intersection of all the three first. If there is not any such intersection given, then you can manipulate the data and get the intersection. But first try to fill this middle place at the first, right? So if I try to fill the middle place, I know that number of students who study all the three languages is 5. So I know that this place can there are 5 students belongs to this position, right? Then what they are saying is that number of students, then try to figure out these places which are common in two of the sets, right? Then go to the single, right? This is what is majorly you should think of how you should approach a question. But also it depends on different questions. For different questions you have to maybe apply different ways to get the Venn diagram. But yeah, so now we have that who study both French and German. So both French and German is 15 number of students study both French and German. So French and German is 15, out of which I have already placed 5. So how many students study only French and German? That is 10. 15 minus 5, that is 10, right? Only French and German, not 3 of them. So that is 10. Then I have both French and Spanish. So French and Spanish, that is 17 number. So 17, that means that I have 12 number of students who study only French and Spanish, okay? So then again, if I go and see both German and Spanish is 13. So both German and Spanish is 13. So I will have 8 number of students who study only German and Spanish. Now it is also given that 30 students study French. So how many students are left here who we have not included in? So if I just add this up, 10 plus 12 plus 5, that is 27. So if 27, I was having 30 students who study French. So I know for sure that 3 students only study French. They study only French, right? Then I have 40 students study German. So out of 40, I have already included 10 plus 13, so 23. So I will have 17 more students who study only German. Then 50 students study Spanish. So 50 students study Spanish. So out of which I have already included 25. So 25 students study only Spanish. Yeah, you are right. So now I know all the numbers in the Venn diagram. Now the questions become very simple. What you have to find? The number of students who study at least one language. So you have to just ignore these numbers, 17, 3 and 25. They study only one language. So except this, you have to add all the other things up, like the other numbers, 10, 12, 8 and 5. So they so if you just calculate it, then the answer is 35. Let's calculate it. 10 plus 12 plus 8 plus 5, 35. So that is how you can solve this kind of Venn diagram based problems. Okay, so like this is almost the end of our session, the master class. Now you can ask any doubt about any topic you have faced problem, or you want some guidance how to prepare for NSET. uh, you can just post in the chat. I'll answer. Is there any doubt you are facing? If you have any difficulty in any topics, you can ask related questions that were there in this session, or you can also ask preparation related doubt or any kind of doubt about scale or anything. Is there any? uh, no, actually I'm a student at SST. I'm studying in second year here now. But yeah, also I am a teaching assistant here at SST. I used to teach some DSA to some students. So yeah, recording. We'll see. Uh, if I think, yeah, recording will be there in the our platform. I guess I will upload the recording, and it will be free. Yeah, Delta platform and YouTube will upload. Is there any other question? Interview tips. Last time I didn't clear first interview. So you cleared the answer, but you was not able to clear the interview. So for interview also, like on Delta, we have some interview preparation courses also. Uh, but yeah, most probably for interview you have to basically for maths interview, you have to have the good concept clarity to like go through the interview. And also for behavioral rounds, you have to have a very enthusiasm about scalar and computer science basically. So yeah, that is basically the interview tips I can give to you. How much scholarship will be provided for JEE main 92 percentile? So see, scholarship is dependent on many various factors. Like your JEE is one of the factors, but there are many several factors that what are the achievements you have in your school days, what you have done, what are you into coding background, or you have something like that. That is all of the things. They build your total profile, and based on that they select some student to give scholarship. So you cannot be sure that how much scholarship you will get. Okay, are there any questions left, or we can go with the surprise now? Are you all excited about the surprise?